You think you belong to the curious ones, the ones who look up, the ones who ask questions that keep them awake at night, tracing the ceiling with their eyes while the rest of the world sleeps soundly. You think that because you clicked on a video about Mars, about space, about the impossible, you're already on the right side of history. Well, good. Hold that thought. Because what this is actually about, what this is really truly about, is a single problem, so brutally unforgiving that it threatens to make the entire dream of becoming a multiplanetary species collapse before it even lifts off the ground. And if you leave right now, you walk away not knowing the one thing that might genuinely determine whether humanity survives the next 200 years. That is not drama, that is physics, so stay. Because this is going to be a strange kind of conversation. Imagine you're standing outside on a clear night somewhere far from the city. Maybe you drove for an hour just to escape the orange glow of the streetlights, which honestly is the most rational thing a person can do on a Tuesday. You spread a blanket on the hood of the car, still warm from the engine, and you lie back and you look up, and the sky just opens. Not metaphorically. Literally, the sky opens because when you finally escape the light pollution, you realize there are not dozens of stars up there. There are not hundreds. There are so many stars that the spaces between them start to feel like the exception rather than the rule. The Milky Way stretches across the sky like someone spilled something luminous and ancient and never bothered to clean it up. And somewhere in that direction, give or take a few degrees depending on the season, there is a small reddish dot. Not glowing dramatically, not pulsing with science fiction menace, just quietly, stubbornly there, Mars. And maybe you feel something sitting with that, a kind of vertigo that has nothing to do with height, a smallness not humiliating but clarifying. Like the universe just whispered something to you in a language made entirely of distance and time. That feeling, that is the beginning of real thinking. That is where science starts, not in a laboratory, not in a textbook, but in that exact moment when the scale of the thing hits you in the chest and you go, wait a minute. What are we actually doing here? And how small are we, and does any of this make sense? And why is nobody else as freaked out by this as I am? Well, some of us are freaked out. And some of us think that freaked out feeling is the most valuable thing a human being can possess. Before this goes any further, there's something worth saying. If this is the kind of thinking that lights something up in you, the kind of conversation you have been waiting to have, then this is the place for it. Every week, questions like these get turned into exactly this kind of exploration. Subscribe, because the universe is not going to stop being astonishing just because the algorithm moves on, and leave a comment. Seriously, write down the one question about Mars, about space, about our future out there that you have never heard anyone answer properly, because those unasked questions are where the real discoveries hide now. Back to Mars. And to the problem, here's what almost nobody talks about when they talk about going to Mars. They talk about the rocket, they talk about the fuel. They talk about the radiation shielding and the food supply, and whether Elon Musk is the right person to be leading the charge or whether he is just the most theatrical. They talk about the landing, which frankly is terrifying because Mars has just enough atmosphere to cause problems and not enough atmosphere to actually help. It is the worst of both worlds, atmospherically speaking, like living in a city where it sometimes rains but the rain is made of gravel. But almost nobody talks about the return. And the return is where the physics becomes almost personally insulting. To understand why, let us take a step back. Because Richard Feynman always said that if you cannot explain something simply, you do not understand it well enough. So here's the simple version. Getting somewhere in space is hard, getting back is, in many critical ways, harder. And the reason comes down to a concept that sounds polite and academic, but is actually one of the most tyrannical equations in the known universe. It is called the Tsiolkovsky rocket equation. Or as it deserves to be called, the equation that makes rocket engineers cry at their desks. Here's the essence of it. To accelerate a spacecraft, you burn fuel. Simple enough. But here's the savage part. The fuel you need to carry for the journey is itself mass. And that mass requires more fuel to accelerate. And that additional fuel is also mass, which requires more fuel, which is more mass. Which requires And you see where this is going. It spirals, it compounds. It becomes a tyranny of exponential mass, where every kilogram you want to move from one planet to another demands an almost obscene quantity of propellant just to get it moving, and then more propellant to slow it down. And then, if you want to come home, you need to do the whole terrifying thing again from the surface of a planet where there is no launch infrastructure, no fuel depot, no ground crew, and a gravity well that, while friendlier than Earth's, is not exactly going to be polite about letting you leave. Mars has about 38% of Earth's surface gravity. That sounds manageable, and in isolation it is. The problem is that manageable is doing an enormous amount of work in that sentence. Because you're not just fighting the gravity on launch. You're fighting the mass of everything you needed to survive the journey there. Everything you need to survive on the surface, all the equipment for the return vehicle, the fuel for the return vehicle, and the fuel to get the fuel for the return vehicle to Mars in the first place. The math compounds in a way that starts to feel almost philosophical. Like the universe is not just making this difficult, it is making a point. And here's what nobody in the popular conversation is quite saying clearly enough. As of right now, with the best propulsion technology we have access to, a crewed return mission from Mars is not just expensive and logistically complicated. It is, in any practical sense, on the edge of impossible, not because we lack the courage or the vision, or even entirely the money, because we lack a solution to the fuel problem that does not require us to either pre-position fuel on Mars before humans arrive, which is its own extraordinary challenge, or develop propulsion technology that does not yet exist in operational form. This is the real problem, not the going, the coming back. And now let us talk about why this matters in a way that goes beyond engineering. Let us talk about what it means, because this is where the existential weight of the thing starts to make itself felt. Human beings have always had exits. Every explorer, every sailor, every person who walked into unknown territory did so with some version of a path back. Even when the path was dangerous, even when the odds were brutal, the return was at least theoretically possible. Shackleton's men drifted on ice floes. Magellan's crew circumnavigated a planet. Lewis and Clark crossed a continent, but in all of those journeys, the physics of return was not the obstacle. The physics of return was just difficulty, and difficulty is something humans are extraordinarily good at overcoming when they are sufficiently motivated. Mars changes that. Mars says this time it is not just difficult. This time, the equation itself is the adversary. And the equation does not get tired. The equation does not feel sorry for you. The equation just sits there, immovable, made of logic and reality, and it waits. And here's where the philosophical terror starts to creep in. Because what happens to a civilization that reaches the edge of its own physical constraints? What happens when ambition outpaces physics? There are a few possibilities, and not all of them are comfortable to look at. One possibility is that we solve it, we develop new propulsion, we figure out in situ resource utilization, which means making fuel on Mars using Martian materials, primarily the carbon dioxide atmosphere, which is 95% of what Mars has to offer in the air department. That is actually a real and active area of research. There are experiments running on the surface of Mars right now on the Perseverance rover that are testing exactly this idea. An instrument called MOXIE, which stands for Mars Oxygen In Situ Resource Utilization Experiment, has already produced oxygen from the Martian atmosphere. Small amounts, proof of concept amounts. But real oxygen, made on Mars from Mars by a machine the size of a lunchbox. That is not nothing, that is genuinely extraordinary. And it points toward a future where a return mission might carry a small chemical plant instead of massive fuel tanks, land on Mars, spend a year or so quietly converting the atmosphere into rocket propellant, and then launch a crew home on fuel that was made right there on another world. But here's the thing about that possibility, the one that should make you feel the tension rather than the relief. It has not been done at scale. It has not been proven at the quantities needed for a crewed mission. It requires infrastructure that does not yet exist on Mars, And getting that infrastructure there requires solving many of the same mass problems that make the mission hard in the first place. It is a solution that exists on paper and in small experiments, but that has not yet crossed the vast distance between promising idea and reliable technology. And this is the crucial moment. This is where the thinking has to get honest, because there is a version of this story where humanity says, "We are close enough, we will figure it out as we go. Let us send people and solve the problems in real time." That version has a romantic appeal. Humans under pressure innovate. Necessity drives invention. There is truth in that. But there is also another version. The version where we sent people to Mars before we had solved the return problem, and then we did not solve it in time. The version where the greatest achievement in human history becomes also its greatest tragedy. Not because of malice or incompetence, but because of impatience. Because of the very human tendency to let ambition sprint ahead of understanding. And here's where the great filter enters the conversation. Here's where this stops being about rockets and starts being about something much, much larger. The Fermi paradox. If you have not sat with this one properly, now is the time. Enrico Fermi, brilliant physicist, sat down at lunch one day in Los Alamos and asked a question so simple and so devastating that it has been haunting scientists ever since. He looked at the numbers. He thought about how vast the galaxy is, how many stars there are, how many of those stars are sun-like, how many of those are likely to have planets and habitable zones, and he did the rough math on how many civilizations might exist or might have existed in this galaxy alone. And then he looked around at the sky and he said, "So where is everybody? Because the numbers suggest there should be somebody out there. Many somebodies. The galaxy is old, older than it has any right to be. 13 billion years of star formation, planet formation, chemistry, time. If even a tiny fraction of the planets that could support life actually developed it, and if even a tiny fraction of those went on to develop intelligence, and if even a tiny fraction of those went on to develop technology, there should be signals everywhere. There should be evidence. There should be, at minimum, traces, and there is nothing, or rather there is silence. The great, eerie, profound silence of a universe that should be full of voices and is not. That silence has a name. It is called the Fermi paradox, and the most disturbing explanation for it, the one that keeps serious astrobiologists genuinely unsettled, is the great filter. The great filter is the idea that somewhere in the progression from simple chemistry to space-faring civilization, there is a step so brutally difficult, so catastrophically hard to pass, that almost nothing makes it through. Almost every civilization that starts the journey hits this wall and does not survive it. The filter annihilates them. And the terrifying question, the one that makes the room go quiet, is this: are we before the filter or after it? If we are before it, if the filter is still ahead of us, then the fact that we have not found other civilizations is because they all failed at roughly the stage we are at now. They reached for the stars. They ran into a problem they could not solve in time. They had the ambition, but not the physics, or the physics, but not the wisdom, or the wisdom, but not the patience, and they collapsed. Extinct, silent, leaving no trace, and we are next in line. That is not science fiction. That is the logical implication of the data we actually have interpreted through the most rigorous frameworks we can build. It is uncomfortable. It is supposed to be uncomfortable. Feynman always said that if something does not disturb you at least a little, you probably have not understood it fully. So here's the question that should be living in your mind right now, the one that does not have an easy answer. Is the return from Mars problem a small engineering challenge on the way to a glorious future? Or is it a symptom of the great filter beginning to close around us? Because here's the subtle and terrible thing about a civilization-ending bottleneck. It does not announce itself with drama. It does not show up with sirens. It shows up looking like a budget problem, like a political dispute about funding, like public interest fading because the mission takes too long and the news cycle has moved on, like a generation of engineers choosing more immediately profitable careers, like a culture that stops asking big questions because big questions are uncomfortable and there's always something more immediately entertaining to look at. The great filter might not be a single catastrophic event. It might be a slow drift, a quiet forgetting, a civilization that had all the pieces and simply lost the will to put them together before something else, something mundane and preventable, took it down. And that is where the existential weight becomes personal. Because you are part of this civilization, you're one of the minds that either keeps the questions alive or lets them go quiet. The choice to engage with this, to think about it seriously, to refuse to let it become just background noise in an overwhelming world, that choice matters, not metaphorically, structurally. Civilizations are made of individual minds, and individual minds are changed by individual moments of genuine understanding. Which brings us to the tools, because a Feynman-style thinker always ends up here eventually. Not in despair, but in method, not in paralysis, but in principle. The universe is terrifying and enormous and profoundly indifferent, and the correct response to that is not to look away. The correct response is to look more carefully and to think more clearly and to build better mental instruments for navigating the thing. So here's the first tool, and it is one Feynman himself embodied in every lecture, every conversation, every time he sat at a bar and explained quantum electrodynamics to a stranger on a napkin. The tool is this: never mistake the word for the thing. Never confuse the label with the reality. When someone says the word radiation, do not flinch at the word. Ask what kind, at what dose, for how long. When someone says Mars mission is impossible, do not accept the word impossible. Ask which specific problem makes it impossible, and is that problem physical law or engineering limitation? Because those are radically different categories. Physical law is a wall. Engineering limitation is a door that has not been built yet. The return from Mars fuel problem is, at its deepest level, an engineering limitation dressed up in the clothing of a physical law. The rocket equation is real. The constraints it imposes are real, but they are not the final word. They are a constraint within which human ingenuity operates, and human ingenuity operating within constraints is literally how every significant technology in history was born. In situ resource utilization is not a fantasy. Nuclear thermal propulsion, which could dramatically reduce travel times and therefore the mass needed for life support, is not a fantasy. It was tested in the 1960s under a program called NERVA and achieved thrust levels that made chemical rockets look modest. It was shelved for political reasons, not physics reasons. The physics was sound. The technology worked. And it is being actively revisited right now by space agencies and private companies who understand what the rocket equation demands. There's also a concept called the cycler orbit, pioneered in concept by Buzz Aldrin. Yes, that Buzz Aldrin, where a spacecraft follows a continuous orbital path between Earth and Mars, never landing on either, perpetually shuttling between them. The crew transfers via smaller vehicles. The cycler itself never needs to land or launch from a planetary surface, which means it is not fighting gravity wells, which means the mass equation changes dramatically. It is not a complete solution, but it is an example of the kind of thinking that reframes the problem rather than battering against it directly. The second tool is this: make your uncertainty explicit. This is something physicists do that most people find uncomfortable, but that turns out to be one of the most powerful habits of mind available. When you do not know something, say so precisely, not just, I do not know. But here are the things I would need to know in order to know, and here's my best estimate given what I have, and here's how confident I am in that estimate. Applied to Mars. We do not know if ISRA can be scaled to mission requirements. Current data, MOXIE produced approximately 6 grams of oxygen per hour in its initial tests. A crewed Mars ascent vehicle would need approximately 25 metric tons of oxygen. The gap between those numbers is real and large, but it is a quantified gap. It is a known unknown, not an unknown unknown, and known unknowns are to a scientist deeply encouraging because they tell you exactly where to point your instruments. The third tool, and this one is the strangest and the most Feynman of all, is this: take pleasure in not knowing. This sounds like it contradicts everything useful, but it does not. It is not complacency about ignorance. It is the recognition that the not knowing is where the discovery lives, The places where the map is blank are where the explorers go. The questions that do not yet have answers are the most valuable intellectual real estate in existence. The return from Mars problem is not depressing. It is, if you can hold it the right way, one of the most exciting problems in the history of the species. Because it is tractable, it is not asking us to violate thermodynamics, it is asking us to be clever, to be patient, to sustain investment and attention across a timescale longer than the next election cycle, which, admittedly, is the hardest thing humans are currently trying to do. But here's what Feynman understood about difficult problems, the thing that made him extraordinary as a thinker and as a teacher. He understood that the emotional relationship you have with a problem determines how effectively you can work on it. If you approach a hard problem with fear, the fear narrows your thinking. If you approach it with irritation, the irritation makes you want to declare it impossible so you can stop feeling irritated. But if you approach it with genuine, sustained, almost childlike curiosity, the problem opens up. You start seeing angles you could not see before. You start noticing that what looked like a wall has a texture, and textures have weaknesses, and weaknesses are where tools find purchase. So the third tool is, stay curious about the thing that scares you. Stay curious specifically about the thing that scares you. The cosmic silence of the Fermi paradox is terrifying. Good. Be terrified and curious simultaneously. The fuel problem on Mars' return is a genuine obstacle. Good. Be genuinely engaged with it, not from a distance as a spectator of someone else's problem, but as someone who understands that the culture that solves it is made of individuals who refuse to stop caring. Now let us talk about something that almost never gets addressed in the popular conversation about Mars. Something that sits quietly underneath all the engineering challenges and only becomes visible when you look at the full picture. It is the question of what going to Mars actually means philosophically for the humans who go and for the species they leave behind. Because here's the thing that the press releases and the promotional videos do not quite capture. The people who go to Mars, in the first missions at least, will not be doing something analogous to any previous human exploration. They will be doing something genuinely new in kind, not just in degree. Every previous explorer left Earth and knew with reasonable confidence that Earth was still there, that it was still home. That the journey, however dangerous, was a journey away from something permanent and towards something temporary. The first Mars crew will leave Earth, and for the duration of their mission, which could be anywhere from 1 to 3 years depending on the orbital mechanics, they will be so far away that real-time communication is impossible. The signal delay between Earth and Mars varies from about 3 minutes at closest approach to about 22 minutes at maximum distance. That means a conversation takes between 6 and 44 minutes just for a single exchange. There is no calling mission control and waiting for an answer. There is no Earth voice in real time. There's just the crew and the Martian landscape and the silence. And they will know, with a clarity that no previous explorer has ever had to hold, that if something goes wrong with the return system, with the fuel production, with the launch vehicle, they are not coming home. Not because of bad luck or weather or hostile conditions, but because the physics of the situation simply will not allow it. That is a new kind of human experience, and it is worth sitting with. Not to be morbid, but because the people who choose to do it anyway, who look at those numbers and that isolation and that risk and say yes, those people represent something important about the species. They represent the part of us that has always, throughout all of recorded history, been willing to go somewhere nobody has been for reasons that transcend individual survival. And that impulse, that specific and slightly irrational and completely magnificent impulse, is probably the most important thing our species has. It is the impulse that carried us out of Africa. It is the impulse that built boats and crossed oceans and mapped continents. It is the impulse that pointed telescopes at the sky and demanded to know what was out there. And it is, arguably, the impulse that the great filter tries to extinguish, because here's the dark reading of the filter. Here's the interpretation that keeps the Fermi paradox from being merely a curiosity and makes it a genuine warning. The civilizations that failed, the ones that hit the wall and did not make it through, they might not have failed because they were stupid. They might not have failed because they lacked the technology. They might have failed because they lost the will, because the hard problems became too hard and the comfortable distractions became too comfortable. Because the generation that needed to solve the fuel problem instead spent its energy on shorter-term rewards. Because the culture that needed to stay curious became slowly and without noticing incurious. That is a filter, a slow one, a quiet one, the kind of filter you do not feel happening to you because it feels, from the inside, like perfectly reasonable choices made for perfectly understandable reasons. Of course, there are other priorities. Of course, the budget is limited. Of course, people are tired. Of course, there are more urgent problems closer to home. And one day, centuries from now, if something or someone is out there looking at the radio spectrum of the galaxy, they will notice that the small rocky planet in the unfashionable arm of the Milky Way went quiet. And they will add another data point to the Fermi paradox. Another civilization that almost made it? No, that is not the story we are telling here. That is not the story we are writing. Because here's what the physics also tells us. The part that Feynman would have insisted on. The part that does not get enough airtime in the doom-oriented reading of all of this. We know the problem. That is extraordinary. We know exactly what the obstacle is. We can quantify it. We can test solutions. We can build small experiments on the surface of another planet and measure how much oxygen they produce per hour and calculate how many of them we would need and design the scaling pathway and identify the engineering, bottlenecks, and work on them systematically with the accumulated intelligence of the best scientific minds our civilization has ever produced. Knowing the problem is not the beginning of defeat. Knowing the problem is the beginning of everything. It is the most important first step. It is the thing that separates a civilization that has a chance from one that does not. And right now, we know the problem. We have experiments running. We have concepts being tested. We have propulsion engineers revisiting nuclear thermal systems. We have orbital mechanics specialists mapping cycler trajectories. We have chemists working on in situ propellant production at scales that would have seemed unreachable a decade ago. We have, in other words, the beginning of a solution. A fragile, incomplete, still being built beginning, but a beginning. What we need now is the culture to sustain it. And culture, beautifully, is something that is built by the choices of individuals, by the conversations people have, by the questions they ask, by what they choose to care about and talk about and think deeply on. That is where you come in. Not as a passive observer of someone else's adventure, but as a participant in the civilization that either solves this or does not. Every time a conversation like this one pulls someone into genuine engagement with real physics, real problems, real stakes, the culture shifts imperceptibly, but actually. Every time someone goes from, "I heard Mars is hard to get back from," to, "Here is exactly why, here's what we are trying, here's what we need," the intellectual infrastructure of the civilization gets slightly stronger. That is not a small thing, that is the whole thing. Feynman used to say that science is the belief in the ignorance of experts, by which he meant that the value of science is not that experts have the answers, it is that the process, the method, the honest engagement with what is known and not known is open to everyone. You do not need a PhD to understand the rocket equation. You do not need clearance to know about MOXIE and what it proved and what it has not yet proven. You do not need to work at a space agency to hold an accurate picture of what it would actually take to bring humans home from Mars. You just need to be willing to think carefully. To hold the complexity without collapsing it into easy optimism or easy despair. To stay in the uncomfortable middle where the real thinking happens. Here's what an honest, Feynman caliber assessment of the Mars return problem actually looks like. The physics of returning from Mars is not currently impossible. It is not blocked by any law of nature that cannot be navigated. It is blocked by a set of specific quantifiable engineering challenges that require sustained investment, clever design, and a willingness to operate at the edge of what we know. The most promising path runs through in situ resource utilization, specifically the production of liquid oxygen and liquid methane from Martian carbon dioxide and subsurface water ice, which we now know exists at the holes and in subsurface deposits, confirmed by radar instruments on multiple orbiters. The SpaceX Starship system is actually designed with this in mind, intended to use methane as propellant precisely because methane can theoretically be synthesized on Mars. That is not a coincidence. That is engineering philosophy built around the rocket equation. The timeline is uncertain, the funding is uncertain, the political will is uncertain, but the physics is clear. The chemistry is understood. The path exists, even if the path is currently unpaved and the weather is unknown, and there are large sections marked with warning signs. And here's the strangest and most hopeful thing. The same civilization that is trying to get to Mars is also the civilization that, in the last 50 years, has landed rovers on another planet and driven them around for years past their design life, has taken a photograph of a black hole, has detected the gravitational waves from two neutron stars colliding 1 billion light-years away, vibrations in space-time so small that they displace detectors less than 1,000th of the width of a proton, has sequenced the human genome, has created vaccines in under a year, has connected nearly every human being to a global network of knowledge. That civilization can solve a fuel problem. The question is whether it will choose to, and that question is answered cumulatively by the people in it. The Fermi paradox is unsolved. The great filter may be behind us or ahead of us, and we genuinely do not know which. The silence of the universe might mean we are rare, which is humbling, or it might mean others have failed, which is a warning. Both interpretations demand the same response. Do not go quiet. Do not become another silent data point. Do not mistake comfort for safety or entertainment for engagement. Keep asking the hard questions. Keep funding the weird experiments. Keep being the kind of civilization that would eventually figure out how to make rocket fuel on a planet where nothing has ever been launched. The return from Mars is not impossible. It is unfinished. And unfinished is the most interesting state anything can be in because it means the next chapter has not been written yet. There is a version of this story, maybe 2 or 3 generations from now, where a small group of human beings stands on the surface of Mars in thin suits against an alien cold, the sky a color of butterscotch and dust. The temperature sitting somewhere around minus 60 degrees Celsius on a warm day, the thin wind barely audible through the suit, carrying the faint metallic smell of the atmosphere, and they watch a fuel tank finish, filling, produced on Mars, from Martian air and Martian ice, and they begin the checklist for ascent, and they lift off, and the ground falls away, and they leave. And somewhere back on Earth, in observatories and living rooms and school classrooms, people watch the telemetry and they know, in a way that changes something in the species permanently, that we are not trapped. That the planets are not just things to look at, but places to go and, crucially, places to return from. That the great filter, whatever it is, wherever it sits, was not us. We passed through it. We were the ones who stayed curious. We were the ones who refused to go quiet. That story is not guaranteed. It has never been less than possible. And the difference between possible and guaranteed is, in a very real and literal sense, the sum of every conversation like this one. Every mind that engages, every question that gets asked, every young person who hears about Moxie and asks, wait, how much oxygen exactly? And then goes and looks it up and gets excited and tells someone. And that, someone tells someone. That is how civilizations survive their filters, not with a single heroic act, with a sustained refusal to stop caring. Feynman once said that he would rather have questions that cannot be answered than answers that cannot be questioned. There is a reason that line has lasted. It is because it describes exactly the right orientation to have toward a universe that is genuinely overwhelming and genuinely strange and genuinely breathtakingly full of problems that need solving. The return from Mars is one of those problems. It is beautiful in its difficulty. It is clarifying in its specificity. It points at exactly the right question for our moment. Are we the kind of civilization that sees a hard problem and stays with it? Or are we the kind that drifts away toward easier things and one day joins the silence? The answer to that question is not written anywhere. It is being written right now. It is being written by the people who look up at the night sky and feel that vertigo and choose, instead of turning away, to lean in, to ask the next question, To stay curious about the thing that scares them, look up tonight if the sky is clear enough. Find that faint reddish point of light, patient and stubborn in the dark. And know that between you and it lies every hard problem our species has ever faced and every hard problem still to come. And know that the distance is not just kilometers, it is decisions, it is culture. It is the collective choice of a civilization that has so far kept asking, keep asking, because the universe is enormous and indifferent and utterly impossibly beautiful, and it is absolutely not going to give us the answers for free. And honestly, that is exactly how it should be, because the asking is the whole point. The asking is what we are,